Students, we have seen the alternative forms of progressive wave in the last class. That means we have calculated many values of theta, that is our angular function theta, and we have got, by putting those values of theta in the equation of a progressive wave, we have got certain equations of the displacement of the particle. Okay. So now let us assume that if the displacement of the particle at time t equals to 0, that means we are assuming that t to be 0. Okay. And if t equals to 0, we have to assume again, let x be equals to 0. That means we are assuming t and x to be 0. Okay. So, while putting t equals to 0 and x equals to 0 in those equation of the progressive wave, we will get the values between plus a and minus a. What is a stands for? A means amplitude. Okay. So, by putting this t and t equals to 0 as well as x equals to 0, we will get the values lying between positive a and minus a, that is negative of amplitude. Okay. So, the phase of the progressive wave can also be different, may also be different. Okay, that means see from this part, it can be also positive a, that is plus a, and it can also be minus a. So the phase of the progressive wave, the phases of the progressive wave, what can be the phases of the progressive wave we have seen in the previous class. So here from this part we can conclude that the phase of the progressive wave can also be different. Okay. So let us assume the initial phase to be phi. Initial phase by phi. Okay, this symbol is called as phi. Okay. See how the symbol looks like. Okay. So, by assuming the initial phase to be phi, we can get the forms of progressive wave will get other forms in which we can express the equation of a progressive wave. We can able to get those equations. So let us write by assuming the initial phase to be phi. So let us write those equations once again. Okay. So what was our first equation? Y equals to a sine just a minute. A sine within bracket omega t minus kx plus and also minus phi. Plus minus, why we are writing? Because the values of the equation can also be positive a, that is plus a, and it can also be negative of amplitude. Okay, so we are writing, combining both the cases, we are writing it as y equals to a sine within bracket omega t minus kx plus minus phi. Okay, so what was our original equation? Previously we had y equals to a sine omega t minus kx. Just previously we had this equation, y equals to a sine within bracket omega t minus kx. So in this part we are just putting plus minus phi. That's it. The other parts of the equation will be same as it is. Okay. So just we are bringing this new term here. Okay. So let us write the other forms. Okay. Of this initial phase. So this is your form number 1. Let us write the form number 2 by this phi. Okay. So y equals to a sine a sine within bracket omega t minus x by v close plus minus phi. This is the second form of the progressive wave. Okay, because previously we had what? We had a sine. Previously we had this equation a sine within bracket t minus x by v. Previously we had this equation, just again like the previous one, form number 1, we are bringing this plus minus phi here. Okay, so let us write the third form. So I'm not writing the initial equations like this equation. After bringing the concept of this initial phase phi, what will be the equation? I'm just writing it again. Okay, so your third form by putting this phi will be a sine third bracket 2 pi by lambda within bracket vt minus x close plus minus phi third bracket close. Okay, so what is our third form? It's just a similar concept. A sine third bracket starting 2 pi by lambda. What is lambda? Lambda means the wavelength. As usually within bracket vt minus x, we had it previously. Another just we are bringing this phi here, that means plus minus phi. Okay, so this is our third form, which closely resembles to our original equations that we have seen in the previous classes. Okay, so let us write the fourth form. Okay, it is y equal to a sine again third bracket 2 pi by 2 pi. Okay, here, okay, I'm writing it. Y equals to a sine third bracket 2 pi t by big T minus x by lambda close plus minus phi. Okay, so like our previous equation, we are writing the fourth form a sine. We are taking 2 pi outside the bracket, so we'll have inside the bracket t by big T minus x by lambda plus minus phi. Okay, so according to the equation, all this equation, we will just number this equation. According to this equation, at t equals to 0 and x equal to 0,